Swayam Prabha. Digital India. Educated India.
Then what is the beauty aspect of this is that they have used very, very high technology in this. And the hit on the nail was that, again, D.R. Mehta's brainchild of making it completely non-profit. It is a very, very complex phenomenon. You can't just take a cast and, put a pipe. You need to have special laser measurement. So the laser measuring devices were brought in from Germany. So as soon as the patient comes, they make him stand on a wall and the laser measure his, whole body and his gait position, and then they would take the dimensions from the laser guided points and then make the process. Because even a small 5 millimeter difference in the way, you work on the process can be very detrimental to the comfort and to the walking style. So, thanks to all the visitors and the promotion which happened with the Jaipur Foot. And then because of accidents in Afghanistan and other places, landmines and all, they have set up huge Jaipur Foot organizations across the world now. And this is the innovation part of our whole course. Till the benefit doesn't reach millions of users and delighted users, we can't say innovation has happened. You can see how many countries the Jaipur Foot has, gone to. The LIMS itself has gone to more than 5,13,000 people. And 23,000 people across the world have set up offices. This is 2016 figures. And then, a lot of professors like Professor C.K. Prahlad showcase this whole innovation as one of the best innovations for the bottom of the pyramid. He calls his book The Fortune at the Bottom of the Pyramid. So here we very clearly see that every year, 16,000 prosthetic fittings are put in. So it's a huge number to, work on and take it forward. So the video I'm going to show you now is done by C.K. Prahlad, his student. A lot of his students and staff came down to India, studied the whole phenomenon very effectively. And what I like about it is it captures, in a very short video, it captures the complete, whatever I've been talking till now, all the aspects of the Jaipur Foot very well.
हमारा ये पहला पैर कटा हुआ है, घुटने के ऊपर से ये सन 76 में कटा, अंगूठा से नाखून थे। उस समय हम खेती का काम करते थे, लड़का था, उसके 5 वर्ष की उम्र, 3-4 साल तक हम ऐसे नहीं चल पाए। उस समय ये सोचा कि जो भाग में हुआ वो तो
We identified the problems of the handicapped in India, and we felt that they suffered not from one but 3 disabilities. They were physically handicapped, and they were financially extremely poor, and thirdly most of them were illiterate. 99.5% of the people who come to us today are below the poverty line.
सन 1966 में 1966 के अंदर मैं यहाँ सवाई मानसिंह हॉस्पिटल के अंदर मुझे लोग लाए थे, बच्चों को कोई काम सिखाया जाए आर्ट का। हमारे दिमाग में आया कि जो है ये जो टायर होता ये बड़ा मजबूत होता है, जो है इसका पाँव बनाया गया तो जो है कामयाबी हो सकती है।
We said we developed a foot. So we developed a design where we filled this with microcellular rubber, this with microcellular rubber, and the upper part was wood. So it can hold the shank. The biggest advantage is this movement which the set foot doesn't have, and there is a movement here. We are giving them a foot piece which has got all the normal movements where they should be, and they last for 4 to 5 years. Because it is made of rubber, the person can walk on uneven grounds, he can climb mountains, he can climb trees, and the best thing is that there is no restraint of working in agriculture areas, because 80% of Indian population is still working in fields, so they can freely work with this on the field, and we don't have to change their profession.
The society's efforts to facilitate a quick and complete return to a more normal life begins with the fabrication of the foot. Jaipur foot pieces are prefabricated. The process is fast and simple, though largely manual. Foot and ankle assembly is made of vulcanized rubber compounds. Individual components are painted with rubber cement. Various toe and foot pieces are assembled together into one unit. Aluminium die is used to cast a normal foot shape. Sole-shaped patterns are placed on nylon cords used for reinforcement. This unit is then covered with skin-colored cosmetic rubber. Die is tightened and placed in vulcanizer. After 20 minutes, foot is removed and is ready for use. With the foot already prefabricated, a patient's day begins at 9 a.m. Once registered and admitted by a doctor, the limb is prepared, marked, and wrapped. A trained technician forms the cast. The cast is removed, and a mold of the limb is poured and dried, then carved to the marked specifications. An ordinary polyurethane pipe is placed in a vacuum forming machine and heated, then stretched over the mold and formed. Once cooled, the mold is knocked loose and removed. A Jaipur foot is then attached and the prosthesis is fitted on the patient. Finally, the patient tests the prosthesis under the supervision of a doctor.
ऐसा है कि जयपुर से भी खबर मिली है और वहाँ से बुलावा है और हमें अच्छा लगा है, इसलिए अच्छा लगा कि हम ज्यों त्यों हम चलने लगे। हम 4-5 किलोमीटर चले जाएंगे और आए भी जाएंगे। हमारा तो सर सब दिन का काम खेती का है, ऐसा तो नहीं कि घंटा से कोई बात करे हो या
Yeah, so there we are. We saw this film made by C.K. Prahlad and his project team. When I visited, there, I found one person who came with the screws which have come off from the shank. The screws had come off, and then he had nailed it. So what happened when you nail a plastic? It will crack. This is the most important part. So then we did a project in IIT, worked for 6 months to design the screw. Can you now guess the screw is going through how many materials? Skin colored cosmetic rubber, which is the vulcanized rubber compound, and the wood, and the fork and the plastic shank. So what used to happen is, through the screw, water used to enter the wooden part through the screw, through capillary action, and the wood will start getting soft. So the screw get loose and it would come off. So then we found out, this best screw, we did research, we found out the correct rake angle, talking to our mechanical engineering professors. We came up with a stainless steel screw. We gave the right drill hole so that the stainless steel screw will fit tight into all the 3 parts. And then we also gave a sealant. That is, once you drill a hole, you put a sealant drop so that the wood gets sealed over there before I drive the screw in. And we supplied that to Jaipur, and they're testing 200 of these, screws which we sent. And if that works, then we would put those screws everywhere. So every small, maintenance issue can be taken in a very good way. So we'll be sending that, and that's our small contribution into this large project. There are 3 sections here: the finger section, midfoot, and the heel. So these 3 sections are separate. Their construction also is like the foot. So the beauty of this design is it can bend. It's beautiful. The type of load, it can bend. It can take all the shocks of jumps and, see how it's bending. So we saw that the affordance is happening because it's reaching, and it is the way it's manufactured. The whole structure of strategic management happened because of the officer. And it is maintenance free because it is single. There are 2 pieces: the single feet foot and the shank. So the maintenance is very, very low. You saw that stocking which is there on the stump. The stocking is specially double woven, cotton stocking, which actually gives all the cushioning to the stump. It plays a very, very vital role, and that also, I believe, comes from Germany because of donations from a German counterpart who wants to, give those stockings to Jaipur. This is irrigation pipes, most probably HDPE. So these pipes are extremely strong because they're used for piping water for agriculture applications. So that's a very important component of the design. Is this high-tech? What is the high-tech aspect of this? Very good. Material. Which material is high-tech here? Of course, the microcellular rubber is high-tech. Why? Because it went through all that research to be produced and available in large sheets, which are used for large applications outside in car industry, in other industries as suspension bushes and other places. And here you're using the best research from automotive to use it in Jaipur Foot, but you're using it in a customized way. Excellent. What is the other high-tech things in this? High-tech materials.
I think the socket is the most important part.
Very good. The socket again is extremely critical. It comes from the best polymer, largest companies, very good strength, very good moldability. It's a thermoplastic material, so you heat it and you very nicely shape it, right? So that is one excellent input. But the third interesting aspect is the rubber cord and the vulcanizing paste and the rubber which is used comes from the tire industry. And can you imagine how much research tire industry would do to generate these raw materials? Very, very high quality raw materials. So I'm using the high-tech aspect in this is all in the raw materials, including this wooden block. The grains of the wooden block has to be in the right orientation so that the screw will not come off. Wood can give you tremendous amount of shock absorption at that level. And what else? The joint. It can give you very good compression for putting the screws in and locking it. So that is the beauty of putting, all the aspects of the, high-tech into this simple product. So every aspect in the Jaipur Foot has multiple advantages, not one advantage. Microcellular rubber, what all it's doing? It's giving me cushioning. It is giving me flexibility. It's giving it moldability. Moldability now I mean building the model. And it's giving me longevity. This microcellular rubber is non-perishable. Here, see, it's all skill. Skill of the people who are getting the job done. So the final fitting and the final design, they actually do it very customized to the people who are there. You saw they were actually heating on the, heating on a heater to, get the shank into the rubber. So there's a joint there and it actually, they fully fitted in. As per design, they have an area that goes fully in and they drill the hole after they fit the shank through and through. So they completely fitted, drill the hole and then put it together. So their size is already measured, they know the sizes and they do it. And that's the whole reason that they don't have too much of standardization. There's another problem of accurate design. So they're working on that, how to modular design so that they can really close in on the inaccuracies if they crop up in the design. But this is all again hand skill which is coming into play. You'll have to come up with some design. So we came up with a design which was like a collar. So you push the pipe and it goes and rests on a collar on the foot. So we made a collar here. It is still not implemented. We gave that design where we made a collar. So when you put the shank, it exactly goes and sits like a socket, like a tiffin box. So we made that, so that there is no sort of dimensional problem because sometimes if it's heated more, it can go in. So we worked for 4 months on that and we sent the design. And what is interesting in all this is, it's like again, Abdul Kalam, now I sit in Bombay and send a design. Will it get implemented? It's a large organization, right? It's a large training. So it has to be in activist mode. You have to be there, you have to train the people, you have to take things forward. Then only things get implemented. So we're planning to take it up, in the next sessions and get the whole, thing implemented. These small finger blocks, microcellular rubber, they were cutting with their hand. It was a very tedious process. So we wanted to help them out and we said we give them punching machines to cut exactly the size of the fingers. So that, input was given by us. So we are working on that also to support the production aspects of the design. Nylon rubber cords, again from tire industry, provide strength and resilience. You're telling why will it come back? Look at the way the tire is designed. It's the same way the foot is designed. Look at the strings which are, and all these are placed, in the right orientation so that you can get the type of resilience you want. All of them are coming on top of those, finger blocks. So when it gets molded with the cosmetic rubber, it all gets sealed. And this actually generally is 20% larger size, 10% larger size than the actual tool. So when the tool presses it, whole thing gets compressioned, and then the rubber flows in all the directions, and you get a very, very solid piece in hand. And basically, skin color. Now they are also trying to get a little darker and lighter shades. What happens with all these organizations is when you have inventory, it becomes very difficult to control. And the type of population which comes over there, they are happy to get a foot. They're really not bothered whether the color of their foot's match. It's that type of, requirement. So we have to really understand the demographics. But if we can give colors, one of the best, but it's quite good. And now coming to the last section of our lecture. So we saw the whole innovation journey, how the whole manufacturing, how the whole materials, and how each material has multiple roles, multiple advantages. And do you think there are different designs all over the world using blade running processes, which is developed in one of the best universities in US, and it's programmed, it's got the best materials. So there are innovations at every level. Will you call this innovation? It's of course innovation. It uses all the ingredients for that context. It could be for one user or two users, but it is happening at that level. Can we apply that to our context? It's very difficult because the whole ecosystem doesn't work. The cost will become too much. We don't have that type of resources. If we had the resources, why not? But if the resources are not there, then it's very difficult. So we need to understand financial implications. But if you look at the other angle of administration and costs and running, that's why your innovation can never reach scale. Similarly, there are microprocess controlled processes. A lot of work is happening on the sea leg. Fabulous designs, fabulous technologies. Very good case studies on the YouTube of how these are developed. And again, same type of passion the designers and the teams are working on for a different context, which is working very well. This again integrated prosthetic legs. Surgically, they have implanted. So you have one part of the prosthesis, which is an implant into the bone. Then what will happen? All my outside problems, remember I was talking about customization, all that is gone, right? It's already into your bone, and all your gait will be perfect. Your orientation will be perfect, and that operation also has to happen very effectively. And then you can attach the best, computer controlled, numerical controlled processes to control your gait. It will learn how you walk, and it will program itself to give you the best gait. And you can't even make out that you're having an artificial limb. So the technology and research has gone till that level. And we have a lot of examples of this, racing driver who had an, accident, and he has both his legs of that caliber. And with that, I like to close. And we now very clearly know what happens in the journey of design, the technology. Technology can be materials and manufacturing, and the innovation. And innovation comes from the complete domain of understanding the user, understanding the strategic implication, and the whole vision of the person who is running the show, which is D.R. Mehta, of what would I like to do? How will I like to make it completely philanthropic? How will I like to make it a social design and take it forward the largest sector innovations? This is one of the best examples of innovation in the country. So I thought we'll start with this for our whole design and technology, course.